Cool. Yeah, thanks for coming to this session. I'll be talking about the Modern Metadata Platform and what it is, why do you need one, and how do you build one. So just to prefix this a little bit, you might have been to many sessions in the conference so far where it's hardcore tag with demo and all that. This is not it. So you can sit back and relax. The content is a little bit lighter, but it is mostly talking about how we can use metadata to change organization and then make data power the business. Okay, like I said, we'll start it off by talking about what's a modern metadata platform, and I'll abbreviate it with MMP, so it's less a mouthful. And why do you need an MMP as a company organization, and how do we build a great MMP? So before we start, I'll quickly talk about my background and how I think I can stand here and talk a little bit about my experience. So I'm the CTO, co-founder of Metadata. It's a new startup, as you probably guess, specialized in this metadata field. And I'm also the co-creator of a pretty popular open source project called Data Hub. It's probably the most popular project out there right now in this area. And I also prior to starting the company, I was a tech lead in the metadata team at LinkedIn, building, as you guessed, Data Hub for the metadata platform for LinkedIn. So, what is an MMP? I'll start off with your typical, Gartner, Forrester, hype cycle thing. There are two kind of related technology that sort of fall into this category. So the first one, Gartner terms as active metadata management. You can read the description there of what it is. But if I put on my metadata bias glass and read through that, what I see is it essentially say, hey, can you make your metadata actionable? Okay? And if you go down the hype cycle, the maturity ladder, you'll see another interesting technology called Enterprise Data Fabric. Okay, once again, some interesting definition there. You can read through that. But if I were to summarize it with one word or one sentence, you want to enable self-serve through metadata. Okay. So up to this point, I've used the word metadata multiple times already, and you'll probably hear me keep stressing that word over and over throughout this presentation. But what is metadata anyway, and what does that enable people to do? So let's talk about the use cases, because these are the things that you are probably more familiar with, and you may not link them directly to metadata immediately. Data discovery, okay? I would like to see a show of how many people here within the company where they have a catalog or in the process of trying to implement a catalog. Okay, about half of you. All right. One of the driving force here is commonly known as, I want to be able to search and discover my data. Right. It sounds pretty simple, right? How hard could it be? But anyone who have implemented a catalog would have known that it is never trivial. And in fact, I think there's another talk in this probably tomorrow's session, or I forgot, but it talks specifically about how not to build a failed data catalog, essentially, how to do it right. So data discovery is one of the, kind of the very first use cases, because you don't know what you have until you see them, right? So you want to be able to find what you have. Naturally, the next thing that links to that is data lineage, right? Okay, now you know that you have all these tables, all these machine learning models, all these dashboards and whatnot. How are they related? How did you compute one from another? That is also a very important metadata-oriented use case. Data observability. Once again, there's another, I think this morning, there's another session on this specifically. But essentially, it boils down to, I want to make sure that all my pipelines are flowing correctly. I want to have visibility into when something breaks, that I know, and I know who to talk to and how to fix that and so on and so forth. And through lineage, obviously, that's also super important because then you can know what are the downstream impact if an upstream table, say for example, it's not populated correctly. Data governance, this is a very overused word. I think if you ask 10 people what data governance is, you're probably going to get 11 answers, right? So I'm not attempting to define it here, but try to give you a sense of what it is, at least from our perspective, from metadata perspective. You want to make sure that people are doing the right thing, so to speak. You want to make sure that when you have a completely democratized data ecosystem where people are free to do whatever they want, there's some sort of rules or governance around it to make sure that it doesn't become a dumpster, essentially. That's data governance. Data privacy, this one people are probably pretty familiar with. Recently, GDPR, CCPA, all these laws brought these into the forefront. I know a lot of companies, especially if you're based in Europe, have business in Europe, this is one of the most important use cases to them. But in other industry, for example, highly regulated industry, your pharma, your banking industry and all that, data privacy has been around for a long time before GDPR and CCPA and whatnot. So certainly a super important use case from a regulatory point of view. And another thing that's more trending now, because more and more companies are doing sort of ML and hiring people to do data ops and whatnot, there's a lot of operational metadata that is also sort of come into folds with powering the business. And yeah, so that is also another use case, common use case that we've seen with metadata. And beyond the sort of the concrete use cases, there's also some paradigm shift that's happening in the industry. One term that you're probably less familiar with is called data OS. This is kind of coined by Ben from Mode. If you read his blog, you probably know him pretty well. So essentially, this is saying, hey, look, we have a lot of heterogeneous system around in the data ecosystem. Is there any way that we can have a layer where everything can talk to everything else? So essentially, it's kind of saying that, hey, can we standardize all these interfaces in a way? That's probably very familiar with many of you when you hear this term data mesh. Essentially kind of saying the same thing as well. How do you have all these organizations that sort of develop and evolve independently, but still come together when you kind of trying to connect them together? So once again, there's a huge role that metadata play in this case, where you're trying to bring out visibility of, hey, what's available out there, and also having an interface, exactly like what's mentioned here, an interface that's standardized in such a way that all these systems, even though they're heterogeneous, is able to come together in a nice, smooth way. All right, so we have to talk about metadata management. And this is obviously not a new concept. Many of you probably, being in the industry long enough, would have remember, some of the famous vendor, Informatica, and all these people pushing metadata management. So what has changed, right? Why do we want to bring up this thing? Isn't that a solved problem already, since it's been around for such a long time? Well, it is kind of solved, in the previous generation of data system, right? Nowadays, we have the so-called modern data stack, MDS. Prior to that, metadata management is kind of a small thing that is mostly concerning the data engineer. The rest of the company don't care so much about it. And mostly focusing on operational use cases. Okay, did my ETL run? Did it produce the right thing? Okay, I want to see the lineage of my basic base model and all that sort of thing. That's kind of where it was sort of mostly concentrated on. And because of that, a lot of time it is bundled with the ETL software itself, right? When you buy ETL, you get metadata management almost like a given. And because the stack was mostly homogeneous, right? You tend to buy the entire stack from one or two vendors and give you sort of everything in there. So the metadata, by definition, is all very well integrated already, right? Same vendor, same team building it. It's easy to import and export metadata across systems. However, in the era of modern data stack, one of the things is you want to be able to enable these sort of cross-team collaboration. And the use cases is sort of evolved beyond from purely operational metadata into kind of the organizational use cases, like we kind of listed before, right? Because now you democratize the data stack. Now everyone, practically everyone can go in and create a bunch of data assets. How do you make sure that the organization can move in a unified way rather than just everybody doing their own thing? And it's no longer something that is kind of tagged onto the ETL thing anymore, because now you have all these systems that are sort of heterogeneous, and you sort of buy from the best of breed, right? Buy from Databricks, buy Snowflake. You buy from all these different companies. So you end up with many best of breed solutions out there, but then they don't talk to each other. That's the main problem. And then none of them attempt to come out and then talk to each other, set up all these collaboration between different systems. So you kind of need to have a separate system, that separate layer that's cross-cutting, that just try to integrate with everybody else in order to have that integrated view across multiple systems. And because of, like I sort of mentioned before, because of these things are heterogeneous, so they all tend to have their own metadata sitting in a silo, and then they don't talk to each other. So you need to have this system in order to pull out all these silo metadata, put it into a place where it's standardized, and then you are able to enable all these organizational use cases after that. All right, so after all that, let's try to bring out what's a modern metadata platform. Right? From our perspective, the modern metadata platform is this missing link. So on the left-hand side of the graph, you can see you have the persona that are sort of producer-oriented. Your data engineer, your data analytics and analysts. These are the people who are in charge of producing data, all right, bringing in data from various sources. Build up your data models and whatnot. And on the right-hand side, you see all these personas who are mostly the consumer of the data, right? Typically, your data analysts, your business people, and various business use cases. They want to consume from the perspective of BI and all these things. They don't care so much about the underlying technical data, but they care deeply about what's the business use case and whatnot. So trying to bring these very different group of people together, you need to have a glue that basically glue between, on the left-hand side, all these producers and producer-oriented system, and then on the right-hand side, all these consumer and consumer-oriented system. And to us, that is basically the MMP. All right, and I'll share my personal experience working at LinkedIn before, building up this metadata platform. It has a lot of good attribute of your modern metadata stack, modern metadata platform, and it's completely built out of necessity rather than just someone decided to build this out of the blue. So it sort of dated back at this point 6 years ago. The first system built out at LinkedIn is called Warehouse. And in fact, the original author of Warehouse, Eric Sun, is giving a keynote this afternoon, so please make sure you attend that too if you're interested. So this is essentially as simple as it gets for data catalog, right? So the idea was, hey, can we essentially have a simple monolithic app with basic data model, and then essentially write a bunch of crawlers, inspired by Google, right? And then these crawlers will basically go into different systems and pull out all the metadata, and then put it into this app, make it searchable, and there you go, that's your catalog. Comes 2017 and 2018, this is a time when the catalog was sort of forced into evolving into the next generation of product. And then the forcing factor behind this was GDPR. There's a lot of privacy compliance requirement coming in. So the idea is no longer, hey, do you have this simple web app where people can come in and type in and search a bunch of things? It started from that, but now it evolves into, hey, we actually have to have system that talks to all these metadata, and then use this metadata to drive actual compliance-related use cases. So it's no longer simple, can no longer be supported by a simple monolithic app. So in fact, we kind of rebuild this from the ground up, where we build a proper service, metadata platform service. And then we also have some opinionated model around metadata. And all the metadata, instead of coming in from this crawler that basically go and ping system and grab metadata, we flip the table around and say, we'll get the metadata pushed from the ESO system to us directly through Kafka. One of the benefits of that is obviously because you get real-timeness, so you can get metadata immediately. So you don't have to worry about having your compliance system act on top of stale metadata, right? That could be disastrous if you're working on metadata that are 24 hours ago and actually deleting stuff that you're not supposed to delete, for example. That would be pretty bad. So after that, we realized, hey, now we have built a metadata platform. And yes, it supports 2 use cases. It supports the original search and discovery use case, and then also support the compliance use cases. But we have already collected all these useful metadata, and then we can see there's many other use cases we'll be able to support. We're able to generalize the system in such a way that we can enable supporting of all these other additional use cases easily without having to reinvent the wheel every time. And this is a time when we essentially come up with a V3 where we generalize the model in such a way that it's extensible, and then we also have kind of a distributed service plus an app, and then we still kept the push-oriented, push-based metadata ingestion because that was proven to be pretty successful. And then eventually in 2020, we open source the project, and then we actually also rename it to Data Hub simply, and then the rest is kind of history at that point. All right, so moving on to the next part. So why do you need an MMP? Hopefully I have given you enough idea about why this is important, but some of you might still ask, well, what's the big deal? Why do you need a modern version of metadata platform? Why can't you live with an old version of metadata platform, which also supports all these use cases? The first reason why you need a quote-unquote modern version is because of complexity. And by that, I mean your data ecosystem is no longer one centralized piece that is used by a small number of people. Everything is about democratizing it. Everything is about distributing it. Everything is about becoming a lot more fragmented than before. And like I mentioned before, you tend to go and buy all these best of breed SaaS tools, putting them together. And a lot of companies also put in open source solutions. And on top of that, pretty much every company has its own proprietary business definitions and concepts and all that. So if you look at all of that, that is where all these complexity come from. And not just it becomes more complex, it's also a scalability issue. So if you think about a case where, yes, if you only care about cataloging your table, and maybe your dashboard, you're talking about tens of thousands, maybe 100,000 at most. But if you actually want to capture all the metadata generated throughout your pipelines and all that, every single column, every single job that ran, every query, every access history, at that point, you're no longer talking about a small set of data. You're talking about essentially web scale at that point, because all these systems runs millions of times every day, right? So. And if you try to connect them in a graph, very quickly your graph will contain north of hundreds of millions of nodes and edges. And at that point, if you look at it and say, wait a second, this looks familiar. It's no longer a small data problem. It is essentially a big data problem at that point. So to summarize it with one sentence there, I mean, the reason why you need a modern metadata platform is because your metadata can be as complex and as big as your data, and it kind of deserves the right kind of treatment to it as well. So just try to stick them into a MySQL DB or Postgres DB is no longer going to be sufficient. All right. So the last bit I'll go through on some of the principles of what we believe is how to build a great modern metadata platform. Well, actually, this is not hard, because if you look at it, a great metadata platform is the same as a great data platform. These are the typical requirements that you will imagine from a data, you want to ask from a great data system, right? You want it to be scalable, obviously. You want it to be reliable. You want it to be extensible. Okay, the last two is maybe, you want to have a rich API, but certainly the last thing is maybe a little bit less, it's a lot more metadata oriented, less data oriented. You want to be able to easily integrate with it. So scalability, it's not a hard problem at this nowadays. I mean, with all the cloud infrastructure you are able to tap into and whatnot. But it tends to be, what we discovered tends to be the transactional DB is going to be the bottleneck at the end of the day. What do we mean by that? We know how to store a large amount of data, right? There's plenty of, NoSQL, NewSQL, all these systems you can pick from, right? At a very reasonable price. However, storing a huge amount of data is easy. Able to get them, retrieve them in set pattern is easy. But if you want to support a rich set of query, it becomes much harder. If you want to do complex join, good luck with NoSQL DB. Sure, you can probably still do that with NewSQL. If you want to do graph traversal, yes, some database vendor claim that they are able to do graph and will have a graph-oriented interface. But as soon as your graph gets to a certain scale, most of these systems will fail miserably. Right? Translating graph traversal into essentially joins of millions of things over and over again is not going to be very efficient. And on top of that, if you want to do full text search, once again, good luck. Many vendors will say, yes, we do full text search, but it's literally just searching of the tokens and whatnot. Right? If you want to do something fancier, you want to do edit distance, you want to do proximity, you want to do all these other fancier tokenizer and all that, most of the DB will just say, sorry, we're not specialized for that. Go and talk to a search engine. So this boils down to, yes, if you have a database system that is able to support all that, that would have been great. The reality of it, most of the database systems are designed for specific use cases, and they're very good at those. But in order to support all of that, chances are you might have to bring in multiple data systems. For example, if you really want to do graph well, a graph DB is warranted. And if you want to do full text search, like I mentioned before, a search engine-oriented stuff is probably what you want to do, then try to do that on top of, say, MongoDB. Right. All right. The second part is reliability. Okay. And then by reliability, I don't simply mean the service being reliable, because once again, we know how to build reliable service. That's not an issue. How do you make sure your data is reliable? That's where the challenge is. Right. If you want to build reliable service, the general solution is to throw more machine at the problem. Have a lot of redundancy, yes, we can do that, and service can be up and running with high uptime. However, data reliability is a different story. Like I mentioned before, as soon as you bring in another system, specialized data system that's trying to serve those use cases, how do you synchronize between your main source of truth data with all these specialized data systems become an issue. And you want to make sure that they are synced in a real-time fashion, and what if something breaks, how do you get out of that and backfill it? Zero downtime rebuild and bootstrapping of these new systems is also a challenging aspect. And finally, also, you want to be able to capture a lot of these change history and audit trail, because these are where some of the nuggets is, right? Just give you an example. Typical use cases, okay, yes, it's great that you give me the latest schema and columns of a table, but I want to go back in time. I want to see what happens yesterday. I want to see when was the last time something was changed and all that. That itself, information sometimes is even more critical than the current value, so to speak. Okay, and then extensibility. I sort of hinted on this when I talk about the system that we built before. This sort of go down to two ways. One is a completely loosely typed system. You can imagine this as key value pair dictionary type of system. And of course, yes, you have unlimited extensibility because you can stick any kind of key and value in there. But what makes it easy to write makes it extremely hard to read, because now the reader is sort of need to interpret every possible things that's going there, and you don't have a schema to go with. and all that. So loosely typed, yes, you get infinite extensibility, but also it's very hard to use. What about strongly typed? Well, the biggest problem with strongly typed system is you have to do schema evolution, right? You want to make sure that as you evolve, you don't break your old reader, and then your new writer is able to still write the old writer is still able to write the old data, so on and so forth. There's a lot of backward and forward compatibility issue you have to juggle with. And there are some clever ideas. For example, protobuf is a good example. Right? Protobuf 3 basically say everything is optional. Because of that, then you're free to evolve in any way you want, and as long as you don't reuse the field and all that. So that is kind of cheating in a sense, because once again, it's not very different from key value pair at that point. Your client code will become kind of ugly because every time you have to say, is this optional? Does it have this field? And do everything from there. So it is a compromise, but it has its own drawback. So our preference is to go with a strongly typed, evolvable schema system in a way that make your reader and writer's life easier. And talk about APIs. And then the first thing that springs to people's minds, oh yeah, I know, I need to have a REST API or RESTful API. Yes, of course, you need to have a REST API because that's the most common thing that people do. However, as I sort of hinted on before, these metadata are highly connected. So you tend to want to have also a graph-oriented API to that. And unfortunately, there isn't quite a standard out there. Every vendor has their own thing. GraphQL is kind of as good as it gets from our opinion. It is obviously super powerful, popular within the sort of front-end community, integrating with apps and whatnot. But it is also a pretty nice language for graph traversal as well, general graph traversal. And as we mentioned before, yes, it would be nice to have all these crawlers to go and grab metadata, but a lot of time you want to also have these metadata that push to you, and then when something, in reverse, when something changes within the metadata, you also want to be able to notify or interested party in a push fashion. So this push-based API is quite important because you now be able to write application that is reactive. Right? Example, if a table that was not PI before all of a sudden become PII, maybe there's a bunch of things you have to do. Maybe you have to create a ticket, maybe you have to notify someone, maybe you have to actually take actions and whatnot, lock down the access control. So that sort of application, push is probably the best sort of API that they prefer than busy polling the latest value. And the last bit, which is one thing that a lot of people overlooked, is yes, now you have your API that queries your transactional database and all that, but there's also a lot of analytical use cases, right? Things like, okay, I want to see all the table that I have that happened to be accessed in the past 3 days by this person, and I want to run all these fancy query, and yes, I don't care if it takes 5 minutes, 10 minutes, 2 hours to return. There's no transactional requirement there. You also want to have a nice API for those users as well. And this is the part where a lot of designers sort of overlook, because they focus so much on the service side, and then when it comes to the actual analytical side, they basically say, well, let's just dump our DB to the lake or to the warehouse, and then that people sort out there. So having a nice analytical API is also super important. And finally, I'll talk about the ease of integration, okay? And think of this as metadata ETL, right? Because you want to bring metadata from various places into the central system. Obviously, one important thing which is highly related to the previous model thing is how do you version these API, right? You want to make sure that you have a way that you can keep extending it, bringing in additional new, richer metadata without breaking your existing user. But also, this sort of auditability and debuggability is also super, super important, because a lot of time what you discover is you have some central team whose mission is, okay, I need to bring metadata in, but then they have to work with a bunch of other teams which are actually the holder of those metadata. And if you don't have an easy way to track how things were transmitted and how things were sent incorrectly or correctly, it becomes a nightmare, because when something breaks, you have to go and look at so many different logs from so many different sources to eventually figure out what went wrong. Was it the producer that was wrong, or was it the consumer that was wrong? You had to figure out all that thing. So having a pathway that essentially have all these trackability built into it will be super nice. And finally, something is bound to break in this process. How do you backfill your metadata in those cases? Because sometimes you actually cannot backfill the metadata. Some metadata are generated on the fly, and once that thing finished, then you lost it, right? It's not stored anywhere. So one thing that we feel is a pretty good candidate for this sort of integration is through the lake itself, right? Think of it as having people, the producer, dumping the metadata to the lake, and then have the system come in and pick them up from the lake. And the lake itself, a lot of time, already have these things built in already, auditability, bucketability. And when something breaks, you can always easily go back to your S3 buckets or GCS, and then you start grabbing the previous history, historical data from there directly. All right. A quick recap, a great MMP should have scalability, reliability, extensibility, a rich set of API, and then super easy to integrate. All right. I'll quickly fly through these in the interest of time. But yes, in this talk, I talk about what is an MMP, and why do you need one, and how do you build a great one. That's it. Thank you.
Is there any question for Marth? Can take a couple of questions.
People can't wait to grab lunch.
So how do you guys enforce the metadata and with the real data set in sync? Because sometimes people update the pipelines, but doesn't update the metadata.
Sorry, can you repeat that again? I didn't catch the last bit.
Sorry. So how do you make sure the metadata and the real data in sync? Because sometimes there's hard enforcement to make them in sync. Sometimes people update the real data, but the metadata is out of the date.
That's a really great question. So the question was, how do you make sure the metadata and the data themselves are in sync, right? This is where the sort of push-oriented API is way better, right? Of course, when your ETL job finished writing, that will be the ideal time to publish the metadata. Then kind of a crawler-based approach where you just go back every 24 hours or however often to grab the thing. But there is also, sometimes we have seen cases where metadata change that trigger event, but then the system there will also want to double check, go back to the system, go back to the original source system and say, hey, is this the right thing or not? Right? There's sometimes people want to be doubly sure and make sure that they don't accidentally do the thing that they're not supposed to do. They can do that sort of confirmation. And you might say, oh, why isn't that defeating the purpose? Well, sometimes a lot of system, it's easier to grab one metadata entry, right, versus grabbing everything, right? So doing this confirmation is not necessarily very expensive, but trying to grab everything and then over and over again, that itself become much bigger process. I hope that answers your question.
So I noticed you mentioned Data Hub, and I went to the website, and it doesn't seem to directly integrate with Databricks right now. Do you have any advice on anything apart from Unity Catalog, which is a general purpose solution which hits these metrics?
Yeah, so yes, the open source Data Hub is not yet integrated with Delta Lake per se, or Databricks for that matter. I'm doing a shout out for my own company per se, but that is something that we are working on as a startup to make sure that that is well integrated. And one of the things that we're looking at is Unity Catalog, right? Okay. Obviously, that is a great operational catalog for Databricks and a great source of metadata. So that might be the sort of thing we're looking at rather than at a Delta Lake level integration.
Makes sense.
Mars. Thank
All
you.
right, thank you.